Great, thanks so much, Brian. Let me see if, there we go. Okay, so the Bingham Research Center, to reiterate, is located here at the USU campus in Vernal. We focus on environmental research, especially related to energy production, and a big focus of ours is air quality, and including wintertime ozone in the Uintah Basin. I'll give you kind of a brief overview of what we are, maybe how we can be a resource to the folks here. I'll talk a little about where things are with wintertime ozone as well. And I imagine most of you know the background, but just to make sure everyone's on the same page, I'll give a little bit of background about winter ozone, so bear with me if that's not new to you. To start though, so what we do is research to understand especially environmental impacts of energy development, but environmental situations in general. We're a non-political entity. Really our goal, as it says here, our mission is to conduct research that others can use to make better decisions. So our goal is to help you here, folks in government, folks in industry, and anyone else who's interested, understand environmental issues and then make better and better informed decisions about how to deal with them. We do work to measure emissions of pollutants from the oil and gas industry. We measure meteorology and the chemistry of the atmosphere. We also do modeling of the atmosphere to understand the impacts from different activities, especially to understand the wintertime ozone issue. How what we do might be of help to the folks in this audience today. As I mentioned, we have a diverse research capability, and it's beyond just air quality. Colleen Jones, my coworker who's here, does a lot with soil reclamation and moving of chemicals through the water and soil environment. Really, we are here also to provide expertise. So if you have questions about air quality issues in particular, or environmental issues in general, you can get in touch with us. We can talk to your organization, or have a phone call, give a presentation, point you to resources, things like that. You can see my contact information there, or you can visit our website for some of this. We have produced, it would take a long time to count, so I haven't yet, but it's thousands of pages of reports and publications. You can find those on our website. It's probably worth your time to ask us for what you need, and we can direct you. And we've produced a lot of publicly available data sets looking at what's emissions from the oil and gas industry, what's going on with chemistry in the atmosphere here, and things like that. There are also three kind of different ways, I guess, that you could, in a explicit way, become involved with what we do. One is the Ozone Alert Program. What that is we send emails when high ozone is anticipated during the winter. That really is targeted towards the oil and gas industry. So the idea is it costs a lot of money to do things or delay projects to reduce emissions. So with the Ozone Alert Program, we provide information that allows companies to target emissions reductions when it matters most, right? Most of the year, the emissions from the oil and gas industry don't make hardly any ozone at all in the Uintah Basin. It's really only under these certain winter inversion conditions. And so that's the point of that program. If you want to sign up to the program, send me an email with my email address there, or we have a booth just right out there, and you can sign up with a pen and paper to join that program. We also have, it's called the Uintah Basin Ozone Working Group that the Bingham Research Center facilitates. And the purpose of the Ozone Working Group is to bring together, it's mostly regulators and folks from industry to understand the issues surrounding ozone in the Uintah Basin and craft solutions. Again, email me or sign up at our booth out there if you want to be a part of that. We also, in an effort to make sure what we do is relevant to stakeholders, we have a stakeholder input committee that reviews and provides comments on our research plans. If you want to be part of that, again, send me an email or sign up out there. Okay, so now is the review that maybe many of you don't need, but just so we're all on the same page, ozone isn't emitted directly from sources. Instead, VOC and NOx, volatile organic compounds and oxides of nitrogen, are emitted directly from sources, including sources in the oil and gas industry. And then those react in the air to make ozone, and then the ozone can have impacts on our health, especially the health of people with impaired lung function. Emissions of NOx come really from any burning combustion, like from an engine, from a heater, a flare, things like that. Volatile organic compounds come from everything from the deodorant you wear to emissions from the oil and gas industry. There's fewer deodorant wearers in the Uintah Basin in terms of emissions than there are oil and gas wells, so our emissions tend to be dominated by the industry here in the Uintah Basin, just because there's a lot of production and not a lot of people. The particular issue that we deal with is wintertime ozone. This is a really unique phenomenon. Usually high ozone is experienced in urban areas in the summer, like is happening right now in this summer in Salt Lake City. There have been quite a few high ozone days there. This wintertime ozone phenomenon is really pretty much unique to here, and occasionally it occurs in the Upper Green River Basin in Pinedale. These areas, so ozone is formed in the atmosphere from pollution that reacts in the presence of sunlight. Sunlight's the energy, so we have to be at low enough latitude to have enough sunlight, high enough latitude to have some snow because the sunlight reflects off the snow and then has enough energy to make the ozone. We also have to have these really strong temperature inversions that pack pollution close to the ground that I think everyone is familiar with. And then another key ingredient is the oil and gas industry. We don't need to go into the why of that right now. You can ask me about it later if you're interested, but the particular mix of pollution that's related to oil and gas allows this wintertime ozone to form. Most of the time, the chemistry in the winter makes it difficult, and it's especially there's enough organic compound emissions that kind of push things forward and allow it to happen. So as probably everybody knows, the Uintah Basin in 2018 was declared a non-attainment area. The map, the red line, the squiggly line, is 6,250 feet of elevation. The Utah side of that line is the ozone non-attainment area. It's a marginal non-attainment area, which is the lowest classification, or the least regulatorily onerous classification for a non-attainment area. The great news is that even since before that designation happened, we've been moving in the right direction in terms of air quality in the Uintah Basin. This figure, the y-axis shows days that exceeded the EPA ozone standard, and it's specific to the ORAY monitoring station, which tends to be, not always, but it tends to be the one that's the highest and has the most exceedance days. And then the x-axis is winter seasons. So each dot is how many days we exceeded the standard on a particular winter season. The red dots are years without snow cover. That snow cover, without the snow cover, we just don't get the inversions as strong. There's not enough reflection of the sunlight, so there isn't high ozone. So we focus on the blue dots, the years where we have plenty of snow, and you can see a big trend. Some of this is due to better meteorology. We kind of have gotten lucky on some of these years. But even when we factor that out statistically, the trend is still robust. Ozone is getting lower. We have fewer high ozone days in the Uintah Basin on each winter. So the way that they look at this non-attainment is once you're in, then you have 3 years, at least in our situation, 3 years to where they average those years, and we don't need to get into how they do the averaging. And then if you're below the standard on that average, then you can get into attainment of the standard. So the original timeline was the years were 2018 through 2020. You can see them there. You can see that we had a high year in 2019. Because it's a 3-year average, that one high year kind of pushed us over. So really we should have been declared in moderate non-attainment. So that's the next level up, which is much more costly in terms of how to comply with all the rules and regulations that go along with non-attainment. In fact, the Salt Lake Valley also was a marginal non-attainment area and was just put up into the moderate zone. The reason that we aren't there yet is because of this trend. Regulators submitted a petition to EPA to ask for an extension. They said things are getting better. This last year, 2020, of that 3-year period looks really good. Give us some more time. And EPA accepted that for 1 year, and it looks like it's probably going to be accepted for a second year. And if that happens, then we have the years 2020, 21, and 22, which I kind of dumped on the end of this figure here, and they have all been pretty good. And you can see when we have that extension, if that comes through, then we have 3 good years, which are below the standard, at least when we look at the wintertime data. There are some high ozone days in the summer, and there's a regulatory process to strike those from the record because they're caused by wildfires or other events that aren't local pollution. And so assuming that goes, assuming EPA goes along with continuing that extension, assuming things still look good, there is a good possibility the Uintah Basin could actually become in attainment of the ozone standard before long. So that's really great news, and probably just a few years ago, not what we anticipated might happen. As far as why this is happening, I mentioned some of it is been lucky meteorology. A good portion of it, though, is reduction in emissions. And we know some of that reduction is because especially the gas industry in the Uintah Basin has been down. It's really declined by almost 50% since 2013. So with less production, then we have less emissions. Another part of it, and I'll show a little bit more at the very end, is because things have been getting cleaner, or there's been less pollution or less emissions as a percentage of production in the Uintah Basin. So even as production even when we account for the decline, there's a bigger drop in emissions than we could explain just by the reduction in production, if that makes sense. And I'll talk about some of the things that we know are happening. We don't really have an ability yet to say how much of it is decline in production, how much of it is lower emissions per unit of production. We're kind of working on that. But we know it's both of those together. So things are going in the right direction in the Uintah Basin in terms of compliance with standards, avoiding the worst kind of regulations that it seems like we could have faced even just a few years ago. This graph maybe is, if you're not into graphs, you can lose focus and take a drink or whatever. But I just want to point out here at the end that I guess we're not out of the woods yet. That's what I want to kind of get as a message to close with. So this is just this winter that we just came through, and you can see on the bottom there it's just a few days in February and March this year. The red line there is the EPA ozone standard of 70 parts per billion ozone. The squiggles up and down are ozone at 3 sites. Castle Peak is south of Mighton, a little south of where Ovintiv, the company Ovintiv's main office is. And then you know where Roosevelt is, and Ouray is the center of the basin along the Green River. And so you can see there I put snow depth too, so it depends, ozone depends critically on snow. If there's no snow, we don't have ozone, like I explained. So what you can see is a couple of days where the ozone jumped over the standard, or just barely made it over the EPA standard, even as the snow was rapidly melting. We really kind of dodged a bullet this winter. If it had been a little colder, even just a few degrees colder, that snow would have stayed, and we would have had probably more than 4 days over the EPA standard, at least probably at the Roosevelt location. So as we go forward, one thing to keep in mind is that part of the issue, or part of the what will happen, whether we stay in attainment of the standard or whether we have a bad year, it's just the luck of the draw. It's the roll of the dice with meteorology. We could have a terrible winter with lots of, well, terrible in terms of air quality, with lots of snow on the ground like we did in 2019 to push us over the edge. Not quite no matter what we do, but sort of that way. Or we could have winters with less snow, or the snow melts out early and we're okay. So that's something to keep in mind there, okay? So I guess I kind of mentioned this. In addition to meteorology, though, it also depends on what happens with the oil and gas industry. As production increases, that could mean a lot more emissions of NOx and VOC, and then a lot of more ozone. It looks like we're trending in a direction where per unit of production there's less and less emissions, and so some increase can happen without us kind of pushing back where we were from 2010 to 2013 or so. So it depends some on how much production and also what that looks like, right? How clean it is, or how careful things are done to keep emissions at a minimum. I see a lot of encouraging signs from companies here in the Uintah Basin. I know of companies that are installing no-bleed pneumatics, even though that's not regulatorily required. I know of companies that are doing what I think are really innovative, really aggressive leak detection and repair, way beyond what's regulatorily required, because companies understand that it's in our interest to stay out of non-attainment with EPA. Also, there's work to improve vapor capture on tanks that's happening. So most new wells, as you know, have a combustor, so the vapors produced in the tank go to the combustor. What's maybe less well known is a lot of those emissions leak into the atmosphere before they can make it to combustors. But there's a lot of effort happening to keep those tanks and the associated piping tighter, to keep valves and hatches closed so that the organics can make it to those combustors and not participate in ozone production. And then I know of an effort by Utah Petroleum Association that happened this last winter to encourage contractors, liquid haulers, to make sure things are closed and keep emissions as low as possible. So in my view, I think contrary to what Brian said, there's a lot of reasons to be optimistic about air quality in the Uintah Basin, although there's still reason to be cautious. It's definitely not the time to stop worrying about it, but it's the time to look forward to we're going in the right direction. So, and that's all I have. Thank you so much. And I bet we have time for questions. Greg's nodding, so if anyone has any questions, please go ahead.
What's the status now? Is it moderate?
We are a marginal non-attainment area with respect to ozone.
Marginal, then moderate?
Moderate goes next, serious, and then I think it's severe and extreme. And so the way it works is if you are in marginal non-attainment, there's thresholds of concentrations of ozone. And if you don't attain in 3 years, so if you're not below the 70 ppb standard, then you bump up to moderate. So there's no opportunity to float along in marginal. Does that make sense? Yeah, so the danger is if we go to moderate, then one thing that's happens pretty much automatically is a requirement for across-the-board 15% reduction in emissions, which would almost certainly be thrust upon the oil and gas industry. And so that's why I say it would be an expensive place to go. And we're kind of lucky and really very fortunate that we aren't there, and it looks like might not get there.
Yeah, so when if we trigger moderate, then we have to put in an implementation plan?
That's right. That's right. And here, because the jurisdiction is complex with Indian country and land where the state controls the air jurisdiction or whatever, then likely there would be two plans, one a state implementation plan and one a tribal or federal implementation plan.
Thank you.
You bet.
Is there any indication that the EPA might lower the standard?
And I should be repeating the questions. He asked, is there indication that EPA might lower the standard? So I assume you mean bring it down below 70 parts per billion. I think there was a lot of fear about that when Joe Biden was elected. Recently, the decision by the EPA was not to lower the standard. That could change. It could be changed really at any time, but it's likely not to change for a little longer. The concern there is, so they usually do it in at least 5 parts per billion increments. So we're at 70 now, they'd probably ratchet down to 65. At 65 parts per billion, the Uintah Basin and really most of the Intermountain West, including very remote and pristine places, don't comply with a 65 part per billion standard in the summer, even from just natural background emissions. So hopefully there's an understanding in the federal government that really is untenable, at least for the Intermountain Western United States, and that could be why they decided not to ratchet that down right now. Any other questions? Okay, thank you all.